So as introduced, I will be talking about the advantages of using LFAM in composite molds and tooling. In these slides, I will present a few applications, and then I will also give some examples where our materials have been used, and we can deep dive a bit more into what the benefits are of using LFAM versus traditional manufacturing processes. So to continue the introductions, for anyone who doesn't know, I work for Polymaker. I've been with Polymaker now for 6+ years, and this company was originally founded in 2012. And this is a company, one of the first actually, that specializes in extrusion-based materials, thermoplastics, for different extrusion technologies. So primarily our business started in filaments, in FDM, and in 2018 we also started supplying our pellet product, as I mentioned, to Polycore. Some more information about the company. We are a global supplier now for LFAM products, but also filament-based products. In Europe alone, we have 200+ partners, distributors, resellers. So that's not counting globally. And we are the 3D Printing Industry Award winner for Material Company of the Year. We won this twice, 2017 and 2022. Regarding our Polycore product range, what I've highlighted here is what I consider to be the 3 pillars or the main considerations we take within this product range. So with Polycore, we want to start with the material. This is essentially the product, and what we focused on is a material that is driven by the applications defined by the industry. So this is specific for what your business is focusing on, whether it's a composite mold for automotive, marine, aerospace, furniture, you name it. We're thinking about the exact properties you require. In addition to that, we also want to diversify our portfolio, so there is something for every business or customer out there. Secondly, I named this sort of commercial, but it's essentially a commercial mindset. So what we also want to maintain and endeavor to achieve with all of our products is that we're offering them with mindful pricing for the industry they're being used within. We're also considering the availability and lead times, because as some of you may know, you can't wait weeks for a material to show up at your door. You have deadlines with your projects, so we need to enable this also. Finally, we also look at the complete solution. So we don't just provide the material and then turn our heads the other way. We work with partners. We focus on how our material performs on their systems. A partner, for example, is Seed. And then we also work on validating our new products on popular LFAM systems within the industry, developing the right printing parameters that our customers can use depending on their geometry, their system, their material combination. And then we also have started exploring software collaborations. An example of this is a company, Helio Additive, which is a thermal-based simulation software where you can upload your G-code and optimize it for a first-time right print. So to continue into the advantages, I want to start with quite an important one, which is lead time. Of course, lead times can be very long in composite molds and tooling. And what you'll see here is an example from one of a case studies we had with a partner. This is a single walled part that was printed in a series, so they were all connected up, and then we used milling to separate each of these pieces. Usually the problem with a part like this, a thin wall part that would be used for an automotive underbody, is that it would be injection molded. So the time to produce this part, the startup costs would also be very high, and there'd be a lot of labor. With this one, this particular piece, we were able to reduce the lead time by 60%. So it was over 6 weeks production with traditional manufacturing, and it was down to less than 2 weeks for us to produce 20 components. In addition to that, as I mentioned, the startup costs are a lot lower, because for these 20 pieces, we were using around 2 to 3 kilos of material, and it was simply printed and cut, and that's it. In addition, you'll see that this part is also printed, and this is with our filament, so we've got 2 applications here. But that was quickly printed and designed so we could use this mold as sort of the milling brace, which also demonstrates that we have the opportunity to unlock new designs, new applications within the whole production process. It doesn't just have to be the final part. And then this was with our Polycore ABS 5022. So this is a 20% carbon fiber ABS compound. And the reason this material was selected is because it has the equivalent mechanical and thermal properties that you would want for this part, and that would usually be sourced in traditional injection molding manufacturing. So it was a very clear switch to take on this material. They don't change the properties, and they just reduce the lead time. The second application that you can see is actually on the seed booth, just over there. So a lot of concerns also come with this industry, with composite molds and tooling, but also with the transition to LFAM, is what about the waste? What about the excess material? What about the waste that I create with just learning how to use an LFAM system, right? The learning curve can be quite high, and that can be concerning. In addition to that, we can't ignore the concerns, the growing concerns with sustainability. They say that there are a lot more regulations in Europe regarding emissions, and that over 60% of buyers or businesses will consider sustainability when they are purchasing a system or a material or a product. So it's a genuine concern that we think about the waste we are creating, even with a production process that is leaner and faster. With this particular example, this was produced by Alan Harbour Composites. They're based in Brazil. I believe the gentleman is actually on the booth, or will be on the booth tomorrow for a talk, so you can always contact him. And what they essentially did is they used LFAM, they used Seeds FlexBot and RPTG 1030 to produce a mold for a bus engine cover. Usually, these kind of processes, they take a lot of time. We've talked about lead time. We've also talked about a little bit about the cost of materials used for these processes, but also the expertise and the labor involved. With this, they are able to streamline this process by having an LFAM system such as Seeds FlexBot print it and mill it. And then they were also able to save on material. So this part is actually hollow, and it was still durable enough to be used as a repeatable mold. In addition to that, they have their innovative reusable silicone bags, which you can also see on the booth, which means that they could reuse what was once a single-use waste bit of material. So this demonstrates that not only can we be mindful of the waste we are creating with this, we can reduce that, but we can also actually be sustainable. Finally, to cover our products and why it was chosen for this application, our PTG 1030 is a relatively common compound. It's a PTG with 30% glass fiber and also UV resistant, but it has great printability and adaptability to different LFAM systems. It also holds enough mechanical properties to be used in a mold such as this. So when we talk about the learning curve and actually moving towards LFAM as a replacement from traditional manufacturing, this material was an ideal selection. Now, we talked about lead time, we've talked a bit about waste and sustainability, but I imagine a lot of people who are looking here may be considering buying a system, or if they're using the system, surely there's a compromise. Surely, at some point, the properties of a pellet product is not going to match what I get with traditional manufacturing. But what if I told you it's possible to have it all? This is a good example of this. This is our latest pellet product. It's our PC7413, which is a PC with 30% glass fiber. And what we've really focused on with this material is having the optimal performance and properties that you would get within the composite molds and tooling industry. A few of these that I would like to list is the excellent performance. It's HGT of 136 degrees Celsius. So this was targeted for any molds that were going to be subjected to autoclaving temperatures between 80 and 120 degrees Celsius. In addition to that, we subjected the this component to 27-point scanning after it runs through the autoclave multiple times, and we were able to achieve a less than 0.2 millimeter deviation across all of these dimensions. You can actually see some of the points measured here. And then, of course, going back to one of the pillars or considerations we have with these products is we have been very conscious about the pricing of this. Not necessarily that it's a low price or super high, but that it is representative of the industry that it's going to be used within. So then when you're transitioning over to LFAM, you aren't breaking the bank adding this new material. I would also like to add that this is actually an aerospace mold. Unfortunately, we can't disclose the partner at this time, but I think it's quite exciting to also see what some of the applications we have with these materials. And then to go a bit further, we talked about can you have it all? Can you have these properties and also be sustainable and reduce your lead times? To push it a bit further and refer back to our software collaboration with Helio Additive, this part took, I think, a week to print and mill before, and then we used Helio Additive Software Dragon, which allowed us to reduce the print time by another 38%. Not only did it reduce the print time, but it also improved the thermal index across the entire piece. So it predicted what the layer times should be to make sure that the part had the best mechanical properties, but also the fastest printing time and quality. So not only did we go faster with LFAM, we went even a little bit faster with working with a software partner that was innovating improvements. So finally, to wrap up, I have some very nice closing notes in this, so I want to read them. I think we can agree that LFAM is a very powerful and innovative tool. And then by combining this with the right materials, the right partners, the right innovation, we can really make a change to a very traditional but large industry. If you would like to learn more about our new material, you can scan this QR code here. If you would like to learn more about the case study we have on Seed's booth, you can speak to anyone from Seed or myself, or see it just over there. And if you have any additional questions or would be interested in learning more about the Polymaker products, you can scan this QR code or contact the email above or just speak to me. Okay, thank you everyone.